All right, so now we are going to talk about evaluation of transport layer functionality, because last 30 years we learned a lot and realized that UDP and TCP not always suitable for everything. Okay, we are providing updates for them. So far, TCP looked like a better solution, but people started to use UDP and provide reliable communication and so on the application level. So let's look at how this works and why Google is using it. Yes, TCP, UDP, principal transport protocols for more than 40 years now. Different flavors of TCP developed for specific scenarios. For instance, for the scenario of long fed pipes, large data transfer, many packets in flight, loss shuts down pipeline. Wireless networks, challenges are loss due to noisy wireless links, mobility. TCP treat this as congestion loss. Long delay links, then the challenge is extremely long RTTs. Data center networks, latency sensitive. Background traffic flows, low priority background TCP flows, right? There are many different scenarios now, so the challenges are different. So this is why people trying to move on to UDP, which is faster and, solve some of these challenges. So in the HTTP3, I think currently like 15% of the internet already using QUIC. So, in the future, maybe it will be more acknowledged, let's say. So we are going to, have HTTP3 with QUIC. So this is QUIC UDP internet connection, okay? Application layer protocol on top of UDP. Idea is to increase performance of HTTP, deployed on many Google servers, apps like Chrome, mobile, YouTube app, and so on, all right? So if you look at the picture at the application layer in HTTP2, we have, HTTP2, then we have TLS for security and authentication. At the transport layer, we use TCP, and at the network layer, we use IP protocol, right? So in the HTTP3, we will use QUIC instead. Of course, it relies on TLS, by the way. So security comes from there. Instead of TCP, you will have UDP and so on. So the idea is to have, to move from TCP to UDP and solve all of the security or reliability problems at the application layer. So it adopts approaches we have studied in this chapter for connection establishment, error control, and congestion control, again at the application layer. Error and congestion control, readers familiar with TCP's loss detection and congestion control will find algorithms here that parallel well-known TCP ones. So they are trying to have properties of TCP, but using UDP. Connection establishment, reliability, congestion control, authentication, encryption state established in one RTT. Multiple application level streams multiplex over single QUIC connection. Separate reliable data transfer, security, and common congestion control. So let's look at the TLS and, then TCP and then QUIC. So in the TCP handshake, what happens is as follows. You start with TCP three-way handshake. And then if you need security, and of course, most of the time we need it, we use TLS handshake, right? Then send the data. Of course, we haven't talked about TLS yet, so we will talk about it in the future. So TCP provides reliability, congestion control state. TLS provides authentication, crypto state, and so on. So two serial handshakes. In the QUIC handshake, you try to provide it in the one single handshake, which solves the problems of reliability, congestion control, authentication, and crypto state. And this also QUIC solves the problem of hole blocking. So we talk about it when we talk about TCP. Recall that idea was, of course, this was from HTTP 1.1. If you send 3 HTTP gets messages, and if the first one is a large file, you have to wait to download it first and then get the other HTTP GET request, right? Because you send them in a serial way and receive them in a serial way. So, of course, these are encrypted if you use TLS. In the QUIC, they are sent in an independent request, so you can get them in, different orders, as long as you can receive the smaller one first and then get the larger one. Actually, here, after we talk about cryptography, I mean, at this point, it looks like QUIC is fantastic, so let's use it. But it solves, I mean, it has nice features, but many security concerns arises when we use this kind of process, okay? So I will talk about them, but first we need to talk about cryptography. So I stop talking about QUIC here, but later on, we will briefly mention what kind of problems can occur, what can the attacker can do, and so on. Okay. So the summary is as follows. We talk about principles behind transport layer services, multiplexing, demultiplexing, reliable data transfer, flow control, congestion control. So instantiation, implementation in the internet by UDP and TCP protocols. And this will actually covers our discussion for this layer, actually.